Okay, good morning, class. Our topic for today is kinematics, free fall. When we say free fall, that is a body falling under the influence of the Earth's gravitational attraction. So we have this diagram, okay? If you throw an object upwards and then it reaches a maximum point, your velocity here becomes zero, okay? And then throwing an object upwards, you're going to use your gravitational acceleration as positive. Okay? When the object is falling, or if you throw an object downwards, you're going to use negative for your gravitational acceleration. For the gravitational acceleration, okay, for planet Earth, for MKS, that is in 9.80 meters per second squared, or some references that is 9.81 meters per second squared. For CGS, that is 980 centimeters, per second squared, and then 32 feet per second squared for FPS. So we have the following equation or selected equation for your free fall. Your distance is equal to your initial velocity multiplied with your time plus the um, half of your gravitational acceleration and then time squared. And then for your acceleration, so G, since this is free fall, so your gravity now or gravitational acceleration is equal to your change in velocity all over your time. Okay. Then we have the following, your third equation, we have your 2gs is equal to vf squared minus vi squared, or 2 times your gravitational acceleration times your s, that is the vertical distance, the object that has traveled, is equal to your final velocity squared minus initial velocity squared. So let's proceed with the following examples. Okay. So Action Chuck is riding the giant drop at Great America. If Upton free falls for 2.60 seconds, what will be his final velocity and how far will he fall? Okay. So we are given with the following values. Okay. Your acceleration now, since he is falling, that is actually equal to negative 9.8 meters per second squared. Okay, this is negative 9.8 meters per second squared. Then your time now at 2.6 seconds. Then he was at rest, so his initial velocity value is 0 meters per second. And then what will be his final velocity? So we have the following unknowns: your final velocity, and then how far will he fall as your d. Now to solve now for your distance when he was falling, okay, the amount of distance he fell. So d now is equal to your initial velocity multiplied with your time plus half of your gravitational acceleration multiplied with your time squared. So substituting the following values, we have your 0 meters per second multiplied with your 2.60 second as time plus your half of your negative gravitational acceleration, negative 9.8 meters per second squared. This is negative because it is falling. Multiply it with the given time at 2.60 seconds quantity squared. Gives us your distance at negative 33.1 meters. Okay. This is negative because he fell downwards. Okay. To solve now for your final velocity, we are given with this formula. We can use this formula actually from your uniformly accelerated motion. Okay. Your final velocity equated to your initial velocity plus your gravitational acceleration multiplied with your time. To solve now for your final velocity, substitute the following values for your initial velocity, that is 0 meters per second, plus the negative gravitational acceleration because he was falling. Okay, that is in negative 9.8 meters per second squared, multiply it with the recorded time at 2.60 seconds. Gives us your final velocity at almost negative 26 meters per second. Okay, so we have the following explanation for your velocity. Why is it negative? Negative indicates direction. Okay, that was downward, okay, or south. So that so your values for your Final velocity for this problem is in negative. Okay, let's proceed with the second example. A feather is dropped on the moon from a height of 1.40 meters. The acceleration of gravity on the moon is given as 1.67 meters per second squared. Determine the time of the feather to fall to the surface of the moon. Okay? So we are given with the following values. Prior throwing the feather, okay, it was at rest, so your initial velocity is 0 meters per second. And then your distance is in negative 1.40 meters because it's downwards. And then the acceleration used here is negative 1.67 meters per second squared because the object is falling. So the negative 1.67 meters per second squared is the value of gravitational acceleration in moon. Okay, so the unknown variable here is to determine the time, so that is t. Okay, to solve now for the distance, we're going to use the following formula as g is equal to vi multiply it with your t plus half of your a t squared. Okay, substituting the following values gives us negative 1.40 meters is equal to your initial velocity at rest, that is 0 meters per second. Multiply it with the unknown variable t plus what else? We have the half of your negative acceleration due to gravity in moon, that is negative 1.67 meters per second squared. Multiply it with your time squared. Okay. Finalizing the whole term as negative 1.40 meters is equal to 0 plus the following. And then simplifying the whole term, okay, to get now your time, that is 1.29 seconds. Okay. So it took 1.29 seconds for the feather to be dropped to the ground of the moon, okay, at 1.40 meters elevation. For your third example, we have the following. A stone is dropped into a deep well and is heard to hit the water at 3.41 seconds after being dropped. Determine the depth of the well. So we are given with the following values. Okay? A stone is dropped into a deep well that is heard to hit the ground. So the 3.41 seconds here is your time. Okay? Initially, the stone, okay, is at rest. So VI now is equal to 0 meters per second. And then since this in the earth, your acceleration due to gravity is 9.8 meters per second squared. Okay, it is negative because it was dropped, okay, downwards. Okay, so we are going to solve for the depth or the distance traveled by the stone downwards. So d now is equal to vi multiplied with your t plus half of your acceleration and time squared. Your d now is equal to 0 meters per second multiplied with your time at 3.41 second plus half of your gravitational acceleration at negative 9.8 meters per second squared. Multiply it with your time squared at 3.41 seconds quantity squared. Simplifying the whole equation gives us your distance at negative 57 meters. Why is it negative? So that is in downward motion. Okay? So it indicate it at a depth of 57 meters. Okay, this is actually a deep distance because your well is deep. And so that concludes my discussion for your free fall. Okay,